Welcome to the presentation on Git security best practices. In this session, we will explore how to secure your Git workflow and repositories, ensuring the safety and integrity of your code. Let's examine some common security threats associated with Git. These include sensitive data exposure within the commit history, unauthorized access to repositories, malicious code injection, insecure dependencies, and weak authentication mechanisms. Being aware of these threats is the first step in protecting your Git environment. Now let's delve into authentication and access control. It's best to use secure shell, or SSH, keys instead of passwords for authentication. Enable two-factor authentication, also known as 2FA, for an extra layer of security. Regularly rotate access tokens, implement fine-grained access controls, and audit access permissions regularly to maintain a secure Git environment. Here's an example of how to set up SSH authentication. First, generate a new SSH key using the command ssh-keygen -t at 25519-c, followed by your email address. Next, start the SSH agent with the command eval, open parenthesis, $ssh-agent, -s, close parenthesis. Then, add your SSH key to the agent using the command ssh-add, followed by the path to your SSH key file. Finally, copy the public key to your clipboard using the command cat, followed by the path to your public key file. Let's explore how to prevent sensitive data exposure in Git. Accidentally committing sensitive data is a common security issue. Use a .gitignore file to exclude sensitive files from being tracked. Implement pre-commit hooks for validation. Store secrets in environment variables, and use secret management tools to protect sensitive information. Here's an example .gitignore file for security. We are ignoring configuration files with secrets, private keys and certificates, and credential files. Make sure to adjust these patterns according to your needs. Let's discuss Git-secrets and pre-commit hooks. Utilize tools like Git-secrets to prevent committing sensitive information to your repositories. These tools scan commits for Amazon Web Services, or AWS, keys, passwords, and other secrets, blocking commits that contain such information. Git-secrets offers customizable patterns for detection and integrates seamlessly with continuous integration and continuous delivery, or CI/CD pipelines. To set up Git-secrets, first install it. Then, initialize Git-secrets in your repository. Finally, register AWS patterns and add any custom patterns as needed. Now let's explore signed commits and tags, which provide cryptographic proof of the author of the code, preventing impersonation attacks. Signed commits and tags ensure commit authenticity, prevent commit spoofing, build trust in collaborative projects, and are often required by security-focused teams. To set up pretty good privacy or GPG signed commits, generate a GPG key. List your GPG keys to identify the key ID. Configure Git to use your key and enable signed commits by default. Let's move on to branch protection and code reviews for securing your workflow. Implementing branch protection rules prevents unauthorized changes and ensures code quality. We can require pull request reviews, enforce status checks before merging, require signed commits, restrict who can push to protected branches, and prevent force pushes to critical branches. Here's an example of a GitHub branch protection configuration file. Protection specifies the branch protection settings. Required _status_ checks specifies that the status checks must pass before a branch can be merged into. Required _pull _request _reviews specifies the number of approvers required and whether stale reviews should be dismissed. Enforce _admins indicates whether administrators are also subject to these rules. Required _signatures specifies that all commits on the branch must be signed. Let's delve into dependency security. Third-party dependencies are a common attack vector. Implement tools to detect and mitigate vulnerable dependencies. It's important to regularly scan dependencies for vulnerabilities, set up automated dependency updates, use dependency lock files, implement dependency pinning, and validate dependency sources. For JavaScript projects, utilize npm audit. With GitHub, you can use Dependabot to automate dependency updates. The version key specifies the version of the Dependabot configuration file. The updates key specifies the packages to update. Package ecosystem specifies the package manager to use. Directory specifies the location of the package manifest file. Schedule specifies how often to check for updates. In summary, here's a checklist of key security practices to implement. For authentication, use Secure Shell, or SSH, keys and enable two-factor authentication, also known as 2FA. In terms of secrets management, never commit sensitive data. Use signed commits to verify code authenticity. Implement branch protection to enforce code reviews. Utilize scanning tools to detect vulnerabilities early. And automate processes by implementing pre-commit hooks. Remember, security is a continuous process, not a one-time implementation. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.